Welcome back to the video lecture series for Introduction to the Art of Programming using Scala. This video begins Chapter 5, and we're going to talk about functions here. Functions are very essential to writing any programs of significant size. In many ways, the appropriate use of functions is something that will distinguish good code from bad code. So it's something that's worth spending some time to make sure you understand properly. Now, functions are not something that should be completely new to you. They are something that you know about from earlier classes that you've done, just like when we talked about variables. And we said that variables were something that you knew about from algebra. Functions are something that you know about from algebra. So, for example, in math, you might write something like this. I don't actually have a superscript on my standard console, but you can understand what that says. It says f of x equals x squared. So here we're defining a function f. It is taking a single argument, x, and often this is referred to as the formal parameter. X is the formal parameter of this function. And then x is the whole function f is defined over on this side, and we say that it's equal to x squared. So this is something that if you were to see this written out in a math context, it would make sense to you. We want to use the same type of construct in Scala. And of course, the reason why you would write this is that then you could say f of 3, and it would evaluate it. It would use the 3 in the place of the x and give you evaluate to the value of 9. And so the idea is that you would define functions for things that are useful to you. So if you were doing something where you needed a quadratic, you might define f to be some quadratic, and then you could refer back to it by a simple name instead of rewriting the entire formula. And that's exactly what we want to do here. Now, how would we transform this into a Scala definition? Because that is not happy, Scala as it's written. So the first thing we need to do is there is a keyword for declaring a function. So when we were declaring variables, we saw that at the beginning we would put val or var. When we are declaring functions, we use the keyword def. So we put def before a function. We give it a function name. We could use the name f here, but just like with variables, it is going to be more common that we use longer names, names that have a meaning to them, that invoke some type of an image in the reader's head. F doesn't really tell you much of anything, so we're going to go here with the name square. Inside of the parentheses, we do have a formal parameter, but this is one place where we actually have to specify a type. We saw that with variables, we generally didn't have to put the type. We could have put colon and a type here for variables when we had like val a equals 5. We could have said a colon int or a colon double. The parameters for a function are one of the few places where you absolutely have to put type information in Scala. So I can't just leave this x and tell Scala to figure out what the type of it. This is one place where I have to specify type. And again, the syntax is name, colon, and then the type. And this could be a longer name. In this case, x is probably sufficiently informative for the person reading the code. After the parentheses, you can put another colon and the type that it's going to give you back. When you square a double, you're going to get back a double in return. Now, This is not always required, and in fact, in this particular example, it is not required. However, it is highly recommended that even when it's not required that you put it there. And the reason is that if you don't put it there, Scala will figure out a type for you, and especially in functions, because functions will get longer than this one that we're writing here, it's very easy to accidentally have it return the wrong type. So what about this side over here? So we have an equal sign, and then we need to put an expression. Now, a lot of times we're going to use blocks of code. So we'd put curly braces, and then we'd put multiple lines of code, multiple statements, with the last one being an expression that is the value we want to give back. In this case, it's fairly short, but hopefully you look at this and you realize this is not valid Scala. This does not mean x squared in Scala. From the last chapter, we saw that the caret is an XOR operator in Scala. And when it's used on numbers like this, if you read the extra section in the book, you know that this would do a bitwise XOR, which is definitely not what we want to be doing. The simplest way to express x squared would just be to type in x times x. There is in the math library a POW function, and so you could say the math.pow of x and 2, and this would raise x to the second power. Not only was this more typing, though, it turns out that it's a lot slower than x times x. You would use math.pow if you were raising it to something like the 13th power, where typing it in multiple times is a problem, or if the power is fractional. If you're going to raise it to the 5.6 or to the 2.3, you can't do that very easily with multiplication. So, having typed that in, we can hit enter, and we can see here that this comes back and it says it's defined square, which has the type of x is a double, and it gives us back a double. Now, in the math notation, I said we would have done something like f of 3. We want to use this function. We are going to do exactly the same thing. So we give the name of the function, and then we follow it by parentheses and an argument list. This was a fairly simple example. We could use some more complex examples. So how about we go and write a function. So in the last chapter, we wrote a little script that gives the quadrant of a point. Well, what I'd like to do here is make another version of this, but I want to make a version that uses a function, and I want it to return to us not a string, and I don't want it to print anything. I want it to return to us, to give back, to result in an int that is the quadrant that the point is in. So I'm going to def quadrant, and I need to pass in the information. Now, in this script, we were reading the information from a user. Here, I'm writing this as a function, so I'm supposed to pass in the value of x and y, not have the user type them in when we call this. The idea is that someplace else, the values came from someplace else. It's just like that f of 3, well, that's where we get the value of 3 from, not from the f of x equals x squared. At that point, we don't know the value of x. And so I want to make this general so that it can take an x, which is a double, and a y, which is a double. And as I said, I want this to return to me an int. Okay, and that int is supposed to be what quadrant the point is in. I put the equal sign, and now I'm going to have a block of code. By the way, the book mentions this. One of the most common bugs when you start using Scala, other than forgetting to close parentheses or curly braces, is leaving out the equal sign. when you write functions. Fortunately, the error message for doing that, if you read through it, says you probably left out an equal sign. So just make sure you read your error messages, and you should be able to notice that. Okay, so inside of here, we want code very much like what we had down here. We need to do a check. Well, if x is less than 0, then we have some possibilities. And they depend upon y. So if y is less than 0, so if both x and y are less than 0, that means that we are in quadrant 3. Now in this case, I'm not using the if as a statement. I'm not going to print something. I'm not going to do something. I just want to give back a value. So I'm using the if as an expression here. And in fact, I have nested ifs that are all expressions. So I don't have any print line. And this is a huge thing for students to work on understanding the difference between print line and between giving back a value. Similarly, the difference between reading values and passing values in. They are very different things, and it turns out that passing values in and returning values winds up being far more useful because of the reusability than reading values and printing values. Okay? Previously, we did things kind of in a way that, this script only does one thing for us, and we can only use it in this one way. However, if we write this as a function, part of the goal would be that maybe we could reuse this function again. So what about in the case when x is not less than 0? Well, we have the same check on y. If they are both 0 or greater, we're in quadrant 1, else we're in quadrant 4. So we can write that, and it's worth showing what happens if we run this right now. So that code, in many ways, is happy. It runs successfully in that there weren't any errors, but it doesn't do anything. Defining a function is just like saying f of x equals x squared. Okay, well, just saying that builds a function, but it doesn't do anything for us. It doesn't use the function in any way. And that's what we've done over here, is we have just made a function, but we're not using it yet. There are two ways that we could use this. So one would be inside of the REPL. So if you looked closely at the colon help, there is a load. And so you can load in a file, and what it does is basically it takes every line from that file and executes it in the REPL and shows you the things that were defined. So quadrant was defined inside of here. And now I can call quadrant. So for example, what is the quadrant of 5, 6? Well, clearly I have a typo in here. 5, 6 should be in the first quadrant. I swapped these two. Now, I just changed that file. If I want to utilize the changes, I have to reload the file. Okay, so 5, 6 is in quadrant 1. -5, -6 is in quadrant 3. And we could test that the others are appropriate as well. So that's one way of playing with these with this, and there are certain applications where you will want to define a whole bunch of functions and then read them in the REPL so that you can utilize them. A lot of times, though, you actually want to have your functions defined inside of a script, and then you want to use them. So if I end this script, and well, let's do a call to quadrant of 5, 6, and then show what happens when we run it. Once again, we didn't see anything print out. And the reason for this is because this evaluation, in the REPL, it prints out what value you get back. In a script, it doesn't. Okay? The script, the only things that you're going to see are the things that are actually printed. So now we get to see that it prints out a 1, and it was indeed quadrant 1. What if I want the x and y points to come from a user, as with the previous script? In fact, we can open that, and we can copy those lines and paste them over here In case you're wondering how I'm doing that, the copy and paste in the terminal is Control-Shift-C and Control-Shift-V. It is not just Control-C and Control-V. And then in place of 5 and 6 here, I will put X and Y. There are two things that are significant to note here. First, I want to show that this works. That was not the command that I wanted to run. So if I run this, it prints it out, and if I enter 5 and 6, I get 1. The other thing to note is that on this line of code, I am declaring a variable called X. And on this line of code, I'm declaring a variable called Y. And I am using those X and Y right here. This line creates variables called X and Y. And it turns out they aren't necessarily the same thing. For example, if I were to pass in the 5 and the 6, this X up here would get the value of 5 when this call is made, and this 6 would get and the Y would get the value of 6 when the call is made. And of course, if I were to call it again with -5 and 63, well, on this call, the X up here would be -5 and the Y up here would be 63. And that wouldn't change anything about these X and Y's down here. One of the things about variables, and this really didn't matter to us previously, but now we're getting to the point where it starts to matter. One of the things about variables is that they have a limited scope. They only exist over a certain range. In the case of a variable that's declared at the top level of a script, it exists from the line that it is declared on to the bottom of the script. But what about this X right here? Okay. Where could we use this particular X? Well, it turns out that things that are passed into a function only exist inside of the body of that function. So that means inside of these curly braces. If we were to declare some other variable inside of here, so for example, let's say that we did val z equals 42. If I try down here to print line z, when I run this, I get an error. It says error, not found value z. And a lot of times novice programmers are confused because they're like, no, I declared my z right here. The thing is, this z is in a set of curly braces. You can actually use the % to jump back and forth, and it highlights them for you. That z is inside of curly braces. It exists from here to here, and then it ceases to exist, so you can't print it out down here. Closely related to this is the fact that in my original code, I have two x's and two y's. I have an x and a y down here, this declaration of x and this declaration of y, and I have basically a declaration of x and y up here. Turns out that the parameters for functions are effectively val declarations. In fact, if I try to change something, if I were to say x equals 6, the error message that you get shows you that. It says reassignment to val. It interprets this x right here to be a val. So this is one of these things that, once again, novice programmers can find confusing. I have one x being declared here and one x being declared here. This isn't a problem. It's just like knowing two different people that are both named Bob. Okay? That doesn't mean they are the same person. They just happen to have the same name. Okay? Here's a variable, happens to be named x. Here's another variable, happens to be named x. They do not have to be the same variable. And in fact, if I change the variable names, so let's say I wanted to call these ix and iy for input x and input y, well, that's perfectly fine. That doesn't break anything, because the name of this variable down here and the name that I was passing in right here are not directly related to the name up here. What matters in this usage is the location. The first argument is going to be the x, and the second argument is going to be the y, because of their location up here, not because this one is called x and that one is called y. So that's it for this video, we've shown you how to declare some basic functions, the Scala syntax for doing them. We'll come back in the next video and look in more detail at other things that we can do with functions.